OBS. Alright. Hopefully the new version's really nice. Alright, let's see. Okay. So, I initially made all the interaction components, like the levers and the buttons and the dial or whatever, in Blueprint, because I wanted to show how to make your own to people that couldn't code. But it makes a lot of sense now that they're fairly stable, although I still need a little work on the dial and the lever. With the button, I put some recent work into and cleaned up, and it's stable. To move them to the back end, to C++, and make them more official and easy to work with. So I will leave the Blueprint versions up and around as references, but I probably won't be touching them anymore. They'll just stay in the testing folder, and I'll be moving them all over to C++. And the first one I've moved over is the button, obviously, because it's the most stable. And I wanted to show how to use the new C++ button, because I got questions about it. And it's really simple, but I wanted to go over some of its features as well anyways. So I'll be adding it to this console component, console actor. So edit console actor. We're going to go up to add component in VRButton, which the button is VR agnostic, so the name is not necessary, but I mean it's for VR plugin. So alright, so now we have a VR button in the at 00 on our actor, and we need to assign a static mesh to it, which can be anything. I suggest use a static mesh with a very clean collision on it. This button top I specifically cleaned up the collision on because the default was a little rough. And the more simple and more clean the collision is on it, the better the overlap detection will work on the button. But any random mesh will do. And let me pull it out a little bit so it's more visible. And I mean right there it's already a functional button. It works with default settings. And if you go into event graph and you click on the VR button, you go down at the bottom on button state changed, you bind to that event, then you can simply do something like a print string to print the current button state and go in, and it's true, it's false, it's true, it's false. The default button is a toggle button, so it'll toggle between states as you hit it. Now the ones like on the console here, I have them set up with a material instance, and I change the material color. It'd be depending on its state. It would be very easy to do that with this random one too. I'm just not going to show it because that's just a material instance. Alright, so onto the button settings. We have the event for the button, simple, lets you know when it's changed. The button itself is based off of its relative space to its parent. So the way that it works is a component, and I wanted it to be a component to begin with because most buttons that I've seen for VR are done as actors, where it has a static mesh child component, and I don't like that because you either have to use a child actor component or you have to just keep it as a separate actor, and it's kind of messy. I like the concept of just, you know, like right here, just throwing a button into an actor and it works. So the way that it works as its own component is on begin play, it records its initial starting position relative to its parent, or if there is no parent, relative to the world. And it uses that to define how far it should move off of overlaps and where it should return to when it's released. This means that if you manually move it in world space, like if it's its own actor and it's the root component and you move it in world space, or if it is a child to an actor and you move it in relative space, you'll want to reset its initial location. So under VRButton it has a reset initial button location function. And this will just tell the button to re-record where it should be at all the time. So on release, or where it should do all of the button presses off of, is this initial button location. It shouldn't be required to use it too much because you generally don't move these things in relative space. For the keyboard specifically, I have to use this because when I spawn all of the buttons, I don't expose the initial location on spawn. So it immediately calls begin play on the keyboard buttons and gets the wrong location because then I move them to where they should be on the keyboard. So I'll have to call this function on that. You generally won't need to use this at all. Alright, so we have the button, we have it working in Z currently. Let's go over some of the settings. Button state, its initial state. It can be true or false. It's normally off initially. It's an obvious one. Depress speed is how quickly it returns after you've depressed it. So this one, this is 50. 50 is pretty fast. Oops, I wasn't showing the window. Alright, here. 50. 50 is pretty fast. It just depresses like this. Okay. And then you set it to like 150. I'm not used to working in one window. And 150 returns really fast to your hands again. So it's just the depress speed of it. Depress distance is how far back in its own relative space that it will go. So 16 is going to send this button way farther back than 8, twice the distance. We have button type. So button toggle return is the default one where it just toggles its state and then returns to its resting position. A button press is more like a keyboard where when you press it down it retains on and when you let go it goes false. So it's like a keyboard one. So if you see it right here, true, false, true, false. And if you change it to button toggle stay, it acts like a toggle button, like in the real world, what they usually behave like, where you press it down and it retains its position, and then you press again and it goes all the way back up. So it might be a little hard to see that difference because I have the settings up. Let me do this. Button engage depth is where it actually switches the button over. Like that's when the power would be on the circuit. And that's useful for, like say the keyboard keys. If you want it to engage before it bottoms all the way out like an actual key, then you would set that to something slightly smaller than the total depress distance. Or in the case of a toggle stay, that's the stay resting position when it's active. So if I set that to, let's say, 14, when it is true / powered on, it will stay at position 14. So it has a little bit of pop back there. It pops back because it's at 14 instead of the full depress of 16. Yeah. Button axis is the axis that it goes negative in, the push direction. I only go positive to negative because you can honestly, if you needed to go the other way, you can just rotate the button. No point in me doing all 6 variations. And you have the z-axis up and down. You can change it to x or y so that it goes in the opposite direction. So like let's say you change it to button axis x and you go out here. Instead of pressing back into it, now it should depress to the side. Yeah, like that. So that gives some flexibility in what kind of meshes you can use. You don't specifically have to model around it. Let me set everything back to defaults here. Min time between engaging is the minimum time between button presses that it'll count. So let's say you're doing a keyboard and somebody is waggling their hands through it really quickly. With the default setting, only every 100 milliseconds will count as a valid key press and actually switch the button state. So that's obviously pretty useful. And I mean that's about it. Since it's in relative position, the button doesn't matter which way you rotate it or how you handle it. It'll just work. So I mean right here we have a rotate